Okay, so now that we've talked about the first two jobs of the nephron, number one being filtration, which occurs in the glomerulus, and number two, reabsorption, where things that escaped into the filtrate that we want back in our bodies are reabsorbed into the peritubular capillaries from the tubules. We're going to pick up now and talk about the third and fourth jobs of the nephron. So job number three is secretion. So let's talk about Sergey. He was just diagnosed with strep throat, and so he's taking penicillin, an antibiotic, to treat it. And since he's been taking the antibiotic, he notices that his urine smells funny and kind of bad, and it actually smells like the penicillin if he smells the bottle of penicillin, right? It's kind of, ugh, it doesn't smell very good. So what is going on here? Well, it's secretion. So secretion also occurs in the tubules. So if you'll recall, not all of the wastes that are in our bloodstream moved into the filtrate. Some did, right? So we had ammonia and uric acid and creatinine that moved into the filtrate, but some stayed behind in the blood, right? Because we weren't moving against concentration gradient. So now we want to get all of these things out of the bloodstream and into the filtrate. So what we want to do now is do some active transport to get the remainder of the wastes that were left behind in the bloodstream out into the filtrate, which will be the urine. So creatinine, urea, uric acid, ammonia, hydrogen ions, and drugs and medications such as penicillin, many of them are going to be secreted. This is going to be active transport, moving them against their concentration gradient because they have been in kind of equal concentrations in the blood and the filtrate up till now. So this is kind of the opposite of reabsorption, right? So secretion, we're moving things from the bloodstream into the filtrate against their concentration gradient because we want to get rid of them. So that's what secretion is. So Sergey, his body recognizes penicillin as a drug, and so his body is going to actively secrete it out into the tubule so it gets peed out of the body. And so by the time the blood leaves the kidney then and gets into those venules and then the renal vein, there's hardly any penicillin left in it. It's all been secreted out into the urine. This is one of the reasons why when you take certain medications, you just don't take one dose once, right? You have to keep taking it. You know, in terms of penicillin, usually at least twice a day because your body is constantly eliminating it. In case of penicillin, you're constantly secreting it out into the urine and getting rid of it from your body. And that's why the urine smells bad. The same thing happens when you eat asparagus. So if you've ever eaten asparagus for a meal and then a couple hours later you go to urinate and you're like, oh yeah, I did eat asparagus today, right? The same thing, that compound that gives asparagus its characteristic smell is secreted actively by the kidneys out of the bloodstream and into the urine. Same process. So disorders of secretion are not uncommon. So if people develop renal failure, which is where the kidneys really lose their ability to do most of their normal jobs, including secretion, because that's active transport, it takes energy, it takes carrier proteins, it takes work. So in people who have renal failure or kidney failure, right, what would happen, right? So if you can't do secretion, you cannot move about half of these wastes in terms of ammonia, urea, uric acid, creatinine from the bloodstream into the urine. So if you look at the urine, there is not going to be as much of those compounds as you would anticipate. There would not be as much, the concentrations of ammonia and uric acid and creatinine would be lower than you would typically expect. And concentrations of those same wastes would be higher in the blood, right? So some are going to be lost in the urine still just via filtration, but without the ability to actively secrete the rest from the blood into the urine, you're still going to have these things left in the urine. And so in fact, one of the ways that we diagnose renal failure is by checking blood creatinine levels. That's really standard. We also check something called BUN, or blood urea nitrogen. Urea, right? We check that waste product because you're not able to actively secrete it from the bloodstream into the urine. So those are how we diagnose renal failure. And so what happens to the person then is that these waste products build up and they interfere with your ability to function normally. So it can be fatal if this is severe and goes untreated. And that is why we have invented dialysis. So dialysis is basically a process whereby we create a conduit through some tubing for people's blood to go out of their body through a dialysis machine, which basically works as an artificial kidney, and then back into their bloodstream. So we kind of create an artificial kidney, run their blood through that, and then back into them to do the jobs of the kidney, to get those waste products out of the bloodstream so that they can survive. As you would anticipate, then, dialysis is something that usually needs to be done several days per week, right? So this is an ongoing, regular process. So let's take a break. And so for your in-class assignment today, you have to tell me what Oliver the TA is up to so that I know you took a gander at this PowerPoint. And he seems to be kind of glaring at me from a black chair in our kitchen on which he is seated, not being very helpful. All right. So job number 4, water balance or water conservation. So let's talk about Wally. He's on the wrestling team, and he's been competing hard all day. He's been sweating a ton. He hasn't had a chance to drink much water at all. And if he's trying to make his weight class, maybe he's purposefully sweating a ton and not drinking much water. And then when he goes to the bathroom, he notices that his urine, there's not very much of it, and it tends to be really dark in color, which is what happens if it's very concentrated. There's not a lot of water in it. And so he wonders, how does my body actually make this happen? So job number 4 is water conservation. So the kidney is really, really important for maintaining water homeostasis. So based on how hydrated or relatively dehydrated we are, the kidneys are going to reabsorb more or less water from the filtrate and back into the bloodstream, right? So I'm sorry about this blurry image, but we're going to move more or less water out of the filtrate and back into our bloodstream so that we don't pee it out. So if we're doing this in large amounts, if we're reabsorbing high volumes of water from the filtrate into the blood, that means the filtrate, the urine, becomes very concentrated, right? It's not very watered down because we've reabsorbed a lot of the water, and so the urine will look dark in color. When no water is reabsorbed or very little water is reabsorbed, then your urine is really watery, and so it's very pale in color and very dilute. So the location where this is going to happen is actually in the collecting ducts. So this is going to occur in the collecting ducts. So the signal, so we need to be able to tell our kidneys how much water they need to reabsorb. And the signal comes from none other than the hypothalamus. So remember, the hypothalamus is really important in homeostasis in many ways. It's important for secretion of hormones. It's important for thirst. It's important for temperature regulation. You'll recall that. And so what the hypothalamus does is if we are a little bit low on body water, it's going to produce a hormone called ADH, which stands for antidiuretic hormone. A diuretic is something that makes you pee a lot. So an antidiuretic cuts down on how much you're peeing out, right? So this is going to open up water channels in those collecting ducts so that water is reabsorbed, so that we can actually move water out of the collecting ducts and back into the bloodstream. So the hypothalamus is going to make ADH whenever we're dehydrated or if our blood pressure is low and it thinks we need to tank up a bit and hold on to what we have. And it will shut off if we're overly hydrated, if we have too much water in our bloodstream. So in Wally's case, right, he was dehydrated. He'd been sweating a lot. He was losing a lot of body water and he wasn't drinking. So his hypothalamus is going to produce ADH that opens water channels in the collecting duct, and then water is reabsorbed out of the filtrator, the urine, back into the bloodstream. So the urine then, because you've moved water out of it, is going to be concentrated and dark in color. So this happens every single night when you're asleep, right? So when we're asleep, we're not drinking any water for 8 hours or more, right? So our body says, we better start conserving, right? Our blood starts to get a little bit more concentrated. So the hypothalamus is going to produce ADH, and that will allow the channels in the collecting duct to open, so we reabsorb water from the urine, which makes the urine more concentrated. So this is why in the morning when you wake up, your first urination of the day, that urine is pretty concentrated. So it's usually pretty dark in color. It's also why if you're doing a pregnancy test, which is looking for the presence of hormone in urine, a first morning urine, which is very concentrated, is going to be the most able to find it early on. Not that you couldn't have a positive test later in the day, and you will eventually, but in the beginning, if you want to try to concentrate that as much as possible, you want that first morning urine. So here's another case, right? So Lily has a gastroenteritis, which is an infection of the stomach and intestines caused by a virus. So she's been vomiting and having diarrhea all day. She calls the student health center for advice, and the nurse asks, well, when did you last urinate and what color was your urine? So this is not an infrequent question that we'll ask in scenarios like this. And so if you think about why are we asking this and what information does it tell us, right? So she's been vomiting and having diarrhea. That's going to cause you to lose a lot of fluid from your body. Chances are too that if you're vomiting that you're not able to drink water to replace that fluid, nor should you even try if you are still actively vomiting, right? It's just going to come back up. So just don't even try until you feel like you can try it. So the nurse is asking this because if she says, well, gosh, I haven't urinated in over 12 hours, or I last urinated 8 hours ago and it was very small volume and very dark, then we know that Lily is getting pretty dehydrated, that her kidneys are having to reabsorb as much water from the urine as they can. Whereas if she said, well, I just urinated a couple of hours ago and it was kind of a medium yellow, right? That would tell us that Lily still has some reserves, right? Her kidneys aren't reabsorbing as much water as they possibly can from the urine because it's not super concentrated. So she's still doing okay and not getting dehydrated. So that can be important for us in kind of determining whether somebody might need some IV fluids or something to help support them through this illness. So just a side note, most cases of viral gastroenteritis, you do not need IV fluids. You'll vomit and have diarrhea for a day or two, sometimes a little bit longer. Most young, healthy people are perfectly able to tolerate that. And you might get a little bit dehydrated for a brief period of time, but usually you'll do just fine. It's rare that you need IV fluids. It does occasionally happen. So here's another case, different situation. So Jack read in a magazine that drinking a lot of water, or on a website, that drinking a lot of water is good for you. So he's purposefully drinking a liter of water every 1 to 2 hours, even though he's not thirsty, right? His brain, his hypothalamus is not signaling to him that he needs that water. So first of all, what does this do to his blood? So all the water that you drink is going to get absorbed from your intestines. Your body does not really have the ability to do very much to say, I don't need this water, I'm just going to let it go out the other end, right? If you drink a whole lot of water, you don't get diarrhea, okay? So we pretty much absorb everything that we put into our mouths in terms of water. So what's going to happen then is this is getting absorbed into the bloodstream in those capillaries in the villus and all those things that we learned about in the digestive system. And so the blood is going to become a little bit more dilute. So the hypothalamus is going to be like, whoa, we are overhydrated. So it's going to turn off ADH. If you don't have ADH, those water channels in the collecting duct close, therefore water is trapped in the collecting duct and cannot get reabsorbed from the urine back into your bloodstream. That's what we want to do in this situation. We want to get rid of that water and not allow it to return into the bloodstream. So in this case, you're getting rid of as much water as you can in your urine, and your urine will look really, really clear or light yellow. So if your urine is really clear or light yellow, chances are you are drinking a little bit too much fluid, right? And as we've learned when we talked about tonicity, that can actually be fatal, right? So water intoxication, if your concentrations of solutes get too low in the blood because you've diluted it out with too much water, that can actually be fatal because then your blood is hypotonic, and that can cause fluid to move in via osmosis to the insides of your cells and cause rupture or lysis of those cells. So you need to be careful. All right, what about our friend Pete? So remember Pete who likes to party and he got pancreatitis when we did the digestive system? Well, he's still not learned his lesson, and so he's out drinking with his friends, and he's drinking quite a bit of alcohol. And he notices that he's peeing a lot, right? And he's like, yeah, I'm drinking a lot, but it seems like I'm peeing like at least as much, if not more, than what I'm actually drinking. And then he keeps peeing kind of all night. And then in the morning, he feels really hungover, right? He feels really awful, and he feels really dehydrated. His mouth is all dry and sticky. He feels terrible. So what's happening in this case? Well, it's interesting. Alcohol interferes with the ability of your hypothalamus to make ADH. And so if you drink a lot of alcohol, you don't have any ADH, and therefore the kidney can't hold on to any water at all. So through this system in the collecting duct. So it gets lost in the urine. So drinking a lot of alcohol can actually cause dehydration, right? Because it interferes with your ability to hold on to and reabsorb water. So that's part of the reason that you feel so terrible when you're hungover, is you tend to be very dehydrated because you've lost more water than you should have because you couldn't produce ADH. All right, so the work of the nephron then. So we have these two parallel tracks of the bloodstream through the peritubular capillaries and the tubules, the proximal convoluted tubule, the loop of Henle, the distal convoluted tubule, and then the collecting duct. Right, so we've got job number 1, filtration. In the glomerulus, water and small particles move out into Bowman's capsule to form the filtrate. And about half of that, at least half of that, stays behind in the blood. Step 2 is reabsorption, mostly in the proximal convoluted tubule. And those molecules that were like, oh wait, I don't want to pee those out, we're going to actively reabsorb those from the filtrate and into the bloodstream. Glucose and amino acids, we're going to reabsorb at about 100%. Sodium, it's going to depend on what's happening with our sodium concentrations and blood volume. In order to reabsorb things at 100% back into the bloodstream, that's going to be an active process, active transport. It requires ATP and it requires carrier proteins. Job number 3 is secretion. Mostly occurs in the distal convoluted tubule, and it's kind of the opposite of reabsorption. In this case, we're moving things from the blood that were left behind in the blood that we don't want out into the filtrate. So creatinine, ammonia, urea, uric acid, all these waste products that were still left behind that didn't move into the filtrate. I mean, some of them did, but not all of it moved into the filtrate. We want to move the rest of it out. This is also an active process, requires ATP. And then finally, water conservation in the collecting ducts. If we are dehydrated or if our blood volume is low, our hypothalamus is going to make ADH. That will open these water channels, and we will reabsorb water from the collecting ducts into the bloodstream. So in summary, here's kind of a graphic example. So the shape along the top is supposed to represent the peritubular capillaries. I'm not skilled enough with PowerPoint to make them all twisty and turny and look the way they do in real life, so it's kind of an abstract representation, right? But you can see that filtration occurs in the glomerular capillary here, and so we have all these solutes that move out into the filtrate represented by these different colored dots. In the proximal convoluted tubule, we are going to reabsorb amino acids and glucose at 100%. We're going to get those back into the bloodstream, active transport. In the distal convoluted tubule, we are going to secrete wastes. We're going to move them from the bloodstream into the tubules, right, so that we get rid of these things that we don't want. And then from the distal convoluted tubule, the filtrate is going to move into the collecting duct. And if we are dehydrated, if blood volume is low, hypothalamus makes ADH, and we will open water channels to also reabsorb water from the filtrate into the bloodstream, causing the urine to be more concentrated and less dilute. So those are the 4 jobs of the nephron: filtration, reabsorption, secretion, and water balance. I look forward to your questions, and next time we'll talk about the non-urinary functions of the kidney. It has some special jobs that it does as well. Thanks so much.